Okay, pre-AP geometry kiddos. This is our first time doing this, so hopefully it goes well. Okay, so we're going to start off with this idea called segment addition. First, it's important to know what a segment is. A segment is a part of a line enclosed by points. Okay. Okay, specifically it looks something like this. We have a point here, a line, and a point here. Okay, a segment has a starting spot and an ending spot always. Okay, it will never continue on forever and ever and always. It starts somewhere, it ends somewhere. Which means we have this idea called a segment addition postulate. Okay, this means I can break a segment. Let me draw a picture. Let me draw a picture up here. Okay, let's pretend I have a segment. Okay, the segment addition postulate says let A, B, and C be collinear points. That means these points all lie on the same line. Okay, so I'm going to throw in another point here, and I'm going to label it A, B, and C. So I have point A, point B, and point C. If B is between A and C, then this is what the segment addition postulate tells me. If I know what AB equals, and I know what BC equals, then I know if I add those two parts of the segment together, I know what AC equals, the whole entire segment. Okay? So a couple of examples. Let's go ahead and work on this right here. Write the segment addition postulate for the points described. Draw a picture to help. Guys, in geometry, if there's no picture, draw one. It'll make your life significantly easier. Okay? R is between L and S. Okay? One of the things that I always do, if it tells me it's between L and S, L comes first, so I'm going to make that my first point. S is the second thing they tell me, so I'm going to put that here. Does it tell me that R is directly between L and S? No. It just tells me that it's somewhere between those 2 points. So really, it doesn't matter where you put it. You can move it closer to one side, you can move it closer to the other side. It doesn't matter. Okay, as long as it's between those 2 points. Segment addition postulate tells me LR plus RS is equal to LS. And that's it, ladies and gentlemen. We haven't thrown in any numbers yet. That's it. Okay? Number 2. L is between N and S. Now I know it's on a segment, so I'm just going to go ahead and draw a segment. N goes here. S goes here. Could you have flipped those? Yes. Okay. L is somewhere in between. So I'm going to put it right here. Okay. Segment addition postulate. NL plus LS equals NS. And yes, it really is that simple. Okay. But now I'm going to throw some numbers at you. Okay. C is between A and E. Okay. So I'm telling you we have a segment. The end points of the segment are A and E. C is somewhere in between there. Okay? For each problem, draw a picture representing the 3 points and the information given. Solve for the missing measurement. Okay? So first, let's go ahead and draw our segment. Now I might throw in some colors here to help us figure some things out, so don't freak out. A, E, C. Okay. Number 1, this problem is saying, well, AC, so from this point to this point, sorry guys, from this point to this point is 24 inches. And from C to E is 13 inches. This problem is asking me, well, how long is the whole segment? How can I figure out how long it is? Simple, just by adding these two things together. So 24 plus 13 gives me 37. So the whole segment is 37 inches. Okay? Number 2. I'm going to draw the exact same picture. We'll label it differently, but it's the exact same picture. So A, E, we have a C. Okay, so this is what I know. CE is 7 inches. So my picture is not drawn to scale. AE is 23 inches. So this whole segment is 23 inches. I want to know how long is AC. And we're going to call that X. Okay, so let me pick a color here. In green, I'm going to write out the segment addition postulate. Okay, AC, which is X, plus CE, which is 7, is going to equal AE, the whole thing, which is 23. So now we have an algebra problem. To solve for X, we're going to take 23 minus 7. AC is 16 inches. Okay, these are your 2 practice problems to do before class tomorrow. I expect them to be done, and I will be double checking to see if they are. Okay, so make sure you do them. Okay, so let's go ahead and look at this one. These are the types of problems that we will most definitely be seeing the most. Okay, refer to the figure and given information to find each measure. So I know that A to C, this whole entire thing, is 39 meters. Okay, I know that AB is 2x minus 8, and I know that BC is x plus 17. Okay, because I feel it's important to show all my steps, I'm going to. Okay, first thing is we're going to write out the segment addition postulate. So AB plus BC equals AC. So now we're going to plug in everything that we know. AB is 2x plus 8. Or I'm sorry, 2x minus 8. That's a minus sign. Plus BC, which is x plus 17, equals AC, the whole thing, which is 39. Okay, so we're going to combine like terms. I'm going to circle all my x's and box all the constants so I know what I'm adding together and what I'm avoiding, because now we're going to solve for x. Okay, so 2x plus x is a 3x. Negative 8 and 17, when I add those together I get a positive 9 equals 39. So if I subtract 9 from both sides, 3x equals 30. So x has to be 10. Okay, so I'm going to go ahead and plug right up here where it says x equals 10. Okay, so to solve for AB, I'm going to plug 10 in for x. So AB equals 2 times 10 minus 8. Okay, so I have 20 minus 8 gives me 12. So AB is 12. And to solve for BC, I can do the same thing. BC equals 10 plus 17 equals 27. Okay? ladies and gentlemen, that is the segment addition postulate. Okay? You have this one, sorry, right above midpoint. It's almost identical to the one that we just did. I want you to do it tomorrow, or do it before tomorrow for practice. Okay? Moving on to midpoint. I like midpoint. I think it's fun. Okay? I'm going to switch up my colors. I use a lot of purple, and I really love blue, so let's switch it a little bit. The midpoint, by definition of something, is, guys, it's in the middle. The midpoint is always in the middle, smack dab right in the middle. Whatever's on one side is equal to whatever's on the other side. Okay? So the midpoint M of segment AB with these two endpoints, so if I draw a picture here because it's important, if I know that this is A and this is B, and A is x1, y1, and B is x2, y2, then the midpoint M in the middle the x-coordinate of the midpoint is going to be x1 plus x2 divided by 2. And the y-coordinate of the midpoint is y1 plus y2 divided by 2. Okay? So I thought I would help you out a little bit here. Point A is the point farthest left. Point B is the point farthest right. Okay? Now, unfortunately, these little lines here in these examples are supposed to go on the top of those letters, so that kind of stinks. But let's go ahead and work these out. If PQ has endpoints P, which is -4, 1, and Q, which is 2, -3, then the midpoint M of PQ lies in quadrant 3. So very quickly, just to remind us, our quadrants go 1, 2, 3, and 4. So this first problem is telling me, well, if the line has endpoints here, then the midpoint has to be in quadrant 3. Okay, so let's prove that it's in quadrant 3. The first thing I'm going to do is I'm going to label my x1, y1, x2, y2. So the very first point they give me, x1, y1. The second point, x2, y2. Okay, so let's go ahead and find this midpoint. So to find the x-coordinate, we're going to take -4 plus 2 divided by 2. And to find the y-coordinate, we're going to take 1 plus -3 divided by 2. Okay, so 4 plus -2 is -2 over 2, which is -1. And 1 plus -3 is also -2. Divided by 2 is -1. So we're looking at a midpoint of -1, -1. Is that in quadrant 3? If I graph it, boom, 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 it is in quadrant 3. Okay? So example 2, if RS has endpoints R3, 5, so I'm just going to go ahead and label it. It's the first one they give me, that's x1, y1, which means S has to be x2, y2, then the midpoint lies on the y-axis. Okay, so just as a reminder, because I think some people get confused, I'm going to highlight the y-axis in pink. So that pink line, I can't even trace a straight line, y'all. So that pink line right there is going to tell me where the midpoint is. It better be somewhere on that line. Okay? So let's go ahead and figure it out. So example 2. The x-coordinate, we're going to take x1 plus x2 divided by 2. And the y-coordinate, we're going to take y1 plus y2 divided by 2. To find x, a lot of people will say, Miss, it's undefined. 0 divided by anything is 0. This is 4 over 2, which gives me 2. So my midpoint is at 0, 2. If I plot that point, 0, 2, it is somewhere on that crazy pink line that I tried to highlight and make it look nice, but it's not. Okay? So it is on the y-axis. Okay? You have a couple of problems to practice here yourself, so give them a shot. Okay? And last but not least, what if you're given the midpoint? Oh, it'd help if I put it on the video. That'd be smart. Stark. Okay. What if you're given the midpoint and an endpoint, and you're asked to find the other endpoint? Okay. We're going to use the exact same equation that we've been using before. So x equals x1 plus x2 divided by 2, and y equals y1 plus y2 divided by 2. Now, on the other side, I put an m with an x. I'm going to reverse that really quick because this x right here, I'm so bad at centering things. This big x right here is the x of the midpoint. This y right here is the y of the midpoint. Okay, and you're going to see what I do and why I do it. Okay, so let's go ahead and just jump right into these examples. Okay, I'm giving you the endpoint, and I'm telling you to solve for, or I'm giving you one endpoint, I'm giving you the midpoint, and I'm asking you to solve for the other endpoint. So one of the things that I like to look at, or that I do because it's habit, is the endpoint they give me, I always label it x1, y1. It's just habit. I always do it. Midpoint, this will be the xm and the ym. So I'm going to focus on the x's first. I'll do the x's in purple and the y's in green. Okay? So x's, I'm going to plug into this x formula. I know xm, that's negative 9, equals x1 plus, I don't know what x2 is, so I'm going to write x2 divided by 2. Ladies and gentlemen, now we have an algebra problem. Okay, now we solve for x, get it by itself. Step 1, we're dividing. If we divide by 2, in order to get that 2 out of there, I have to multiply by 2. When I multiply this whole side by 2, the 2's cancel out. If I multiply the right side by 2, let me draw that line because some people need it for algebra. If I multiply this side by 2, I have to multiply this side by 2. So I get a negative 18 equals negative 1 plus x2. So to get x2 by itself, we add 1 to both sides. Negative 18 plus 1 is negative 17. So that's part of the endpoint. Okay? I still have to solve for the y part of the endpoint. So we're going to plug it in to the y equation right here. So we have a negative 10, because that's ym, negative 10, equals y2, or y1, so 9, plus y2 divided by 2. Okay, so we have to get rid of the 2. Let's go ahead and multiply both sides by 2. So negative 20 equals 9 plus y2. So to solve for y2, subtract 9 from both sides. Negative 29 equals y2. So for question number 1, I'm going to write it right here. my endpoint the missing endpoint is x, so negative 17, and then y, negative 29. Okay? Now, after doing that problem, is there an easier way for us to simplify these? Okay? I think there is an easier way. Okay? We know that when we plug everything in, we have to multiply each side by 2. So what if, for an easier way, what if we did 2 times xm equals x1 plus x2? And 2 times ym equals y1 plus y2. Makes our lives a lot easier, and I know that you're probably looking at this going, Miss, we could simplify that even farther. You're right, you can. But I'm not going to go there. Not today anyways. Maybe eventually I'll take it there. Okay? Well, let's go ahead and look at number 2. My example number 2. Okay? Now remember, because it's a video, y'all can pause it, go back and rewrite things and solve things out. Okay? First thing I'm going to do is I'm going to label my stuff. I have an x1, y1, and then an xm and a ym. Okay? And I'm going to use the easier way to solve. So 2 times xm equals x1 plus x2. So negative 20 equals 5 plus x2. Negative 25 equals x2. That's a lot faster, don't you think? So to solve for ym, we're going to do 2, or I'm sorry, not ym. To solve for y2, we're going to take 2 times ym equals y1 plus y2. So negative 4 is 2 plus y2. Subtract 2 from both sides. Negative 6 equals y2. So my missing endpoint is negative 25, negative 6. Okay? Now, ladies and gentlemen, I understand that I still have an example to do. I want you to give your practice problems a shot. Okay, these 3 down here. Be ready to go when class starts tomorrow. I don't want this video to be extraordinarily long. Okay, that's why I'm stopping. All right, if you have any questions, message me on Canvas or email me tonight. But those are the end of our notes. Okay.